A journey through time, fact or fiction. Imagine stepping into a machine, twisting a dial and being whisked away to another era, the thrill of the unknown, the excitement of exploring a different time. It's a concept that has fascinated us for generations. Perhaps you'd rub shoulders with dinosaurs, witnessing the colossal creatures roam the earth, or share a cup of tea with Shakespeare, engaging in a conversation about his timeless works. Time travel has captivated the human imagination for centuries, weaving its way into our books, films, and dreams. From H.G. Wells' The Time Machine to blockbuster movies like Back to the Future, the allure of bending time has never waned. But is it truly possible? Could we one day unlock the secrets of time and bend it to our will? Scientists and dreamers alike have pondered this question, delving into the mysteries of the universe. While the idea might seem like pure science fiction, the nature of time itself, as revealed by modern physics, hints at tantalizing possibilities. Concepts like wormholes and the fabric of space-time suggest that time travel might not be entirely out of reach. Our journey begins with a simple question: what is time? Is it just the ticking of a clock, or something far more profound? We experience it as a steady, linear progression, always moving forward. Days turn into nights, and years pass by, marking the passage of our lives. But what if this perception is merely an illusion, a quirk of our limited human perspective? Could time be more fluid, more complex than we ever imagined? What if the past and the future are as real and present as this very moment? What if they coexist with the now, just out of our reach? To grasp the true nature of time, we need to delve into the mind of a genius who revolutionized our understanding of the cosmos, Albert Einstein. His theories opened up new dimensions of thought, challenging our very perception of reality. Before Einstein, most people thought of time as a universal constant, ticking away at the same rate for everyone, everywhere. It was as if the universe had a single, synchronized clock that governed all events, no matter where you were or how fast you were moving. Einstein shattered this notion with his groundbreaking theory of relativity. His ideas were revolutionary, challenging the very foundations of classical physics and altering our understanding of the universe. He revealed that time is not absolute but relative, intricately intertwined with space to form a four-dimensional fabric called space-time. This was a radical departure from the Newtonian view, where time and space were seen as separate entities. Imagine a vast cosmic trampoline. This trampoline represents space-time, a flexible and dynamic entity that can be warped and curved by the presence of mass and energy. Massive objects like stars and planets create curves in this fabric, much like bowling balls placed on a trampoline. These curves are not just abstract concepts, they have real, observable effects on the motion of objects and the flow of time. These curves are what we perceive as gravity. The more massive the object, the deeper the curve and the stronger the gravitational pull. Einstein showed that the stronger the gravity, the slower time flows. Near a massive object like a black hole, time can slow down to a crawl compared to regions with weaker gravity. This phenomenon, known as time dilation, is not just a theoretical concept, it has been experimentally verified countless times. For instance, precise atomic clocks on GPS satellites must account for time dilation to provide accurate positioning data. So, time is not a rigid, unchanging metronome but rather a fluid, dynamic entity that responds to the presence of matter and energy. It ebbs and flows, stretching and contracting based on the gravitational landscape. This revelation opens the door to some truly mind-boggling possibilities, including the potential for time travel. While still in the realm of science fiction, the idea that time can be manipulated offers endless avenues for exploration and discovery. One of the most intriguing implications of Einstein's theory is that time passes at different rates depending on your relative speed. The faster you travel through space, the slower time flows for you compared to someone who is stationary. This effect, known as time dilation, is not merely a theoretical concept, it has been experimentally verified countless times. For example, atomic clocks flown on high-speed jets around the world have shown minuscule but measurable time differences compared to their Earth-bound counterparts. Even more dramatically, astronauts aboard the International Space Station, traveling at thousands of miles per hour, age slightly slower than us on Earth. While the difference is tiny, it demonstrates that time is not a river flowing at a constant rate, but rather a malleable entity that can be stretched and compressed. Section 4. Faster than light, wormholes and the fabric of space-time. The concept of traveling faster than light has fascinated scientists and dreamers alike for generations. If we want to entertain the idea of venturing further through time, perhaps to the distant past or future, we must delve into the mysteries of the universe. We need to consider shortcuts through the fabric of space-time, which could revolutionize our understanding of travel. Here we enter the realm of wormholes, fascinating structures that challenge our perception of reality. Hypothetical tunnels that could connect two distant points in space-time, making the impossible possible. Imagine folding a piece of paper in half and poking a hole through it. This simple analogy helps us grasp the concept. This hole, in essence, represents a wormhole, a bridge through space-time, allowing you to travel between the 2 points on the paper much faster than traveling along the surface, bypassing the conventional route. While wormholes remain purely theoretical, their potential is immense. Their existence is permitted by Einstein's equations, which have stood the test of time. If we could find or create a stable wormhole, it would be a monumental breakthrough in physics and space travel. It could potentially act as a cosmic shortcut, connecting distant parts of the universe, allowing us to travel vast distances across space and perhaps even backward or forward in time, opening new frontiers. However, the creation and stabilization of such a wormhole would require unimaginable amounts of energy, far beyond our current capabilities, far beyond anything we can currently achieve. Yet the pursuit of this knowledge continues to inspire and drive scientific discovery. Section 5. Journeys to the future. A matter of speed? Given what we know about time dilation, could we harness this phenomenon to journey into the future? In theory, yes. If we could construct a spacecraft capable of traveling at a significant fraction of the speed of light, time would slow down for the travelers on board relative to people on Earth. A journey that might seem like decades to the crew could equate to centuries or even millennia back on Earth. Upon their return, the travelers would essentially have stepped into Earth's distant future. This concept, while still in the realm of science fiction, is rooted in the real physics of Einstein's theories. It highlights the mind-bending possibilities that arise when we challenge our conventional understanding of time. Section 6. The treacherous tides of time. Paradoxes of the past. While the idea of traveling to the future, however far-fetched, seems somewhat plausible, journeying to the past presents a Pandora's box of paradoxes and inconsistencies. The most famous of these is the grandfather paradox. Imagine traveling back in time and accidentally causing the death of your own grandfather before your parent was even born. This action would create a paradox, as your very existence depends on your grandfather having lived. Such paradoxes suggest that traveling to the past, if not impossible, would be fraught with danger and unforeseen consequences. It is possible that the universe has built-in safeguards to prevent such paradoxes, or perhaps our understanding of time travel is still too rudimentary to grasp the complexities involved. Section 7. Many worlds, many possibilities, the allure of alternate timelines. One way to potentially resolve the paradoxes of time travel is through the concept of alternate timelines or parallel universes. This idea, often explored in science fiction, suggests that every decision we make, every event that unfolds, could spawn a new, branching timeline. In this view, traveling to the past wouldn't alter our own timeline, but rather transport us to a parallel universe where history unfolded differently. While the existence of alternate timelines remains speculative, it is a fascinating concept that captures the imagination and offers a potential solution to the mind-bending dilemmas of time travel. It suggests that the tapestry of time may be far more complex and intricate than we can currently comprehend.